Hello, welcome, and join us to explore the Eastern Visayas through the lenses of mathematics, a journey of discovery and insight. These are our fellow travelers. We have Jane, Giselle, Marian, and me, Patricia. So, why mathematics? Well, because math is not only about numbers, it's deeply embedded in our surroundings, our decisions, and even how we move from place to place. Join us as we explore Eastern Visayas and uncover how math is reflected in our nature, culture, and everyday life. So, where's Eastern Visayas? Eastern Visayas, also known as Region 8, is located in the central eastern part of the Philippines. With Tacloban City as its regional center, the area is rich in nature, beauty, cultural heritage, and economic activity, all of which reveals the underlying principles of mathematics in various forms. So these are the provinces to visit in Eastern Visayas. We have Leyte, Southern Leyte, Biliran, Samar, Eastern Samar, and Northern Samar. Now let's get on the plane and travel to Eastern Visayas. Now let's get on the plane and travel to Eastern Visayas. Now let's get. I can see your destination. Getting closer, almost there, and here we are in the beauty of Eastern Visayas. And here we are in the beauty of Eastern Visayas. And here we are in the beauty of Eastern Visayas. And here we are in the beauty of Eastern Visayas. And here we are in the beauty of. Now let's talk about the patterns in nature in Eastern Visayas. One of the first things that I noticed upon arriving in Eastern Visayas was the beauty and nature of arts. Beneath the beauty lies mathematics. In the region, patterns in plants and shells follow the Fibonacci sequence, forming efficient growth patterns. The branching of trees and the repeating shapes of coral formation showcase fractals where the same geometric pattern appear on different scales. Here are a few examples of the Fibonacci sequence and the fractals in nature. First, we have the Nautilus shell. The Nautilus shell follows a logarithmic spiral, which expands following the Fibonacci sequence. Then, we have the Philotacci. The arrangement of leaves on a stem, philo- phyllotaxis, often follow the Fibonacci numbers, maximizing sunlight absorption. Then we have the branches of trees and corals. The branches of trees and corals exhibit fractal growth, meaning their smaller parts resemble the whole. Now, symmetry and geometry in arts. Mathematics is also deeply woven into the cultural traditions of Eastern Visaya. The arts of banding weaves, pottery, and textiles, making features symmetrical patterns and tessellations. Now, let's have a few examples of symmetry and geometry in traditional art. The first one we have is banding weaving of Samar. The banding weaving of Samar follows the tessellation principles. Even woven stripes is arranged to create repeating geometric patterns. The second one is the pottery from the Eastern Visayas. The pottery from Eastern Visayas, such as those in Leyte, often feature radial symmetry and geometric precision. Now, what is the real life impact of mathematics in nature and arts? These mathematic principles ensure the balance of harmony and efficiency in both nature growth and artistic creation.
Alright, our next topic will be mathematics and decision sciences. For this segment, we will only cover social choice theory and two of its voting methods. So, what is social choice theory? Social choice theory studies how groups make decisions when there are multiple choices, especially in elections. Conversely, we will apply this to the previous 2022 election for the presidential position, with votes from Region 8 Eastern Visayas. Moving on, the two voting methods we will be studying are first, the majority rule, wherein a candidate must get more than 50% of the votes, and second, plurality rule, to figure out the candidate with the most votes even without majority. This table shows the Region 8 2022 election presidential result, which will be our basis in figuring out two voting methods, majority rule and plurality rule. The column displays the ranks while the rows displays the number of votes. Moreover, the political candidates are represented by the letters A, B, C, D, and E. The A highlighted with red will represent Marcos, B highlighted with pink will represent Robredo. C highlighted with orange will represent Pacquiao. D highlighted with blue will represent Tumogoso. And lastly, E highlighted with green will represent Lacson. Now, our first voting method, majority rule. In this method, the candidate or the choice who received more than 50% of the votes will be proclaimed as the winner of the election. To figure this out, we have to identify the potential candidate with the most votes. This candidate will be A, or Marcus, since he is ranked first 6 times. With the given percentage above, we can add this to know if he garnered more than 50%. After adding, we attain a percentage of 83, which is far above 50%. He is then the winner of the majority rule. The next voting method will be plurality rule. In this method, the candidate or choice with the most first preference votes will be the winner of this method. Ties are also possible and would require a round of vote to be resolved. To figure this out, we will only need to look at the first rank row to determine who among the candidates has the most first preference votes. The candidate with the most first preference vote is A, or Marcos, since he is 6 times the first preferred, and since there are no ties, candidate A or Marcus stand the winner in plurality rule. Note also that majority implies plurality, but plurality doesn't always imply majority.
Aside from mathematics and arts and nature and decision science, mathematics is also used for finding efficiencies, such as finding the fastest route from one place to another, calculating the number of units to achieve maximum profit, or minimizing the expense of a given problem. In other words, mathematics for efficiencies refers to the use of mathematical principles, models, and techniques to optimize processes, minimize waste, and maximize output in various applications. It is divided into three subtopics, which is your shortest path problem, assignment problem, and transportation. However, in this discussion, I will only be discussing one, which is the shortest path problem. The shortest path problem is the optimization problem of finding the shortest or most efficient route between 2 points in a graph. It is widely used in fields like logistics, network routing, robotics, and operation research. A common tool that is used in finding the shortest path problem is the Dijkstra's algorithm, which is a tool for determining the shortest path from one vertex to any destination. So, how can the concept of mathematics for efficiency be applied in Region 8? Well, the Philippines is known to be an archipelago. Therefore, traveling between places or islands is not a piece of cake. However, in Region 8, it is known for one thing: the San Juanico Bridge. The San Juanico Bridge is the third longest bridge in the Philippines. This bridge connects two neighboring islands in eastern Visayas, such as Leyte and Samar. Moreover, this bridge also plays a vital role in the Philippine economy as it facilitates transportation, trade, and tourism between the two regions. With that, the concept of mathematics for efficiency can be applied. Mathematics for efficiency looks into the idea of the shortest path problem, and through this, mathematics can provide a better and more efficient way to travel and transport goods between regions given the distance, time, and cost. To give a better understanding on this topic, let us proceed to an example. So for this example, I used the map of Eastern Visayas to pinpoint different places and connected it with a line. And I've also added the different distances between two places. With this graph, let us find the shortest path and distance from Ormoc to Borongan. The first step for the Dijkstra's algorithm is identifying the starting point. And for our problem, our starting point is Ormoc, so we label that as 0p. Next, we look for the distance of the neighboring vertices. So we have 57t, 101t, and 110t. Once we have figured all of those out, we find or we choose the shortest distance. And the shortest distance among the three values is 57. So that would be 57p instead of t. So therefore it is now permanent. Next, we look for the distance of the other neighboring vertices. So we have 291t, which is the sum of 57 and 234, and 101t, which is the sum of 57 plus 44. So based on the values, the one with the smallest distance is the one with 101. So we change that to a p. Afterwards, we look for the distance of the neighboring vertices. So 101 plus 14 is 115. So given those, which vertex has the smallest distance? So the smallest distance is 110. So from t we change it to p for it to be permanent. Afterwards, you get the distance of the neighboring vertices again. Same goes. So 110 plus 40, that would be 150. So for that vertex, you have two values, 115t and 150t. When choosing the values, you always choose the smallest value. So, between the two values, it is safe to say that 115 is smaller than 150. So, we crash out your 150t and replace it with 115. And since all of the vertices already has a permanent value, it is safe to say that your 291 is also permanent. Therefore, the shortest path from Ormoc to Borongan is 291 kilometers. In conclusion, mathematics for efficiency helps businesses and governments make strategic infrastructure and transportation decisions, improving connectivity across eastern Visayas. In a country where transportation plays a vital role in economic growth, mathematics offers solutions that improve connectivity, efficiency, and overall progress.
And so, throughout our journey, we've seen how mathematics is interwoven into the everyday life of Eastern Visayas. Whether in the natural beauty of patterns and art forms, the structured decisions and voting systems, or the efficiency of transportation networks, mathematics is everywhere. And so, the next time you admire a pattern in nature, participate in a vote, or plan a journey, remember mathematics is at work, making everything more efficient and interconnected.